Hello everyone, this is Poornima Deepthi working as an assistant professor in the Department of Electronics and Communication Engineering in MLR IT. So today I'm going to discuss about the top subject of microprocessors and microcontrollers. And in this microprocessors and microcontrollers series, I would like to explain the concept of introduction to microprocessors. So let us deep dive into the fascinating subject of microprocessors. These are the overviews I will explain today. What are the basics of microprocessors? What are the terms we have been using in the microprocessors? And what is the perfect definition of a microprocessor? And how the instruction will execute in the microprocessors. So this is the basic computer system. So in this basic computer system, our microprocessors plays a crucial role. So can anyone tell where we have been using these microprocessors? So as of now, I was recording this video. So to record this video, we need microprocessor. You are watching this video. If you are watching this video, you need to have a microprocessor. With any device you are using, microprocessor is compulsory. So where microprocessor is compulsory? Why we are using microprocessor to listen or to do videos, anything. So can anyone tell that can we use microprocessor in tube lights? No. Before microprocessor exists, we have been using tube lights. We have been using fans without microprocessors. So where we are using microprocessors? Okay. We are using remote control devices, home appliances, right? So in that home appliances, can we use home appliances without microprocessors like remotes, keys, car keys? Can we use? No. Why there is necessary for microprocessor? Because while we are using keys for cars, we need to have a microprocessor because these cars keys in the cars have been using the program. So to execute a program, microprocessor is compulsory. So why microprocessor is compulsory? Can't we execute a program without microprocessor? No. Until now, those who are programming need to have compulsory a microprocessor to execute a program. So it is necessary to know basic about the microprocessor because nowadays 90% of the people are using programmings. For any applications or anything, we have been using this. So to execute each line of a program, we need to have a microprocessor. So microprocessor plays a crucial role in our lives. So to know basics about the microprocessor is compulsory in this life. So what are the basic components we have been using to execute a microprocessor? Microprocessor doesn't have an input-output elements in it and memory. So we need to support microprocessor with using input-output devices and memory devices. So what are the input-output devices? So the input-output devices are like keyboards, scanners, joysticks to play. So all these things comes under the input devices. And what are the output devices? Output devices, your monitors, printers, pages, all these comes under the output devices. A microprocessor is a integrated chip, a programmable integrated chip which takes the input from the input devices and process the data which we have already stored in this memory. Already it will fetch the data from the memory and it process and again it transfers the data to the output devices like monitors, printers or pages. So this is the process of microprocessor. So it will, how it will execute the instruction? First, it will fetch the data. Second, it will decode the data. And third, it will execute the data. It will fetch the data, it will decode the data, it will execute the data. How it will fetch? So if you are considering this block diagram of a computer system, microprocessor is connected with only input and output devices and memory device. So there is no direct connection between the input output devices and memory devices because without processing, it is it is not important to connect input output devices to the memory devices. There must be a processing unit. That processing unit is the microprocessors. Okay, so it will take input from the input output devices, okay, and it will fetch the data from the memory. How it will fetch the data from the memory? How memory will use it to store? What is a memory here? So a memory is a memory is a block which will store the data. How it will, only data? What is data? Data can either be information. Data is a information, either be in the format of image or text or videos, like those things. Data can be in the format of images, text, videos, so on. So how a memory device is going to store this data? Memory devices store the data, right? But not in the format of image, not in the format of text, not in the format of videos. Then how memory devices are used to store the data? So remember one thing, memory devices can only store the data in the format of binary bits. Always remember this. When I was talking about the memory, you need to picture yourself with the binary data only, not images, not text, not videos. If you know how we are storing the data in the memory, then you will know half of the microprocessor itself. Okay, so here the memory will be stored in the format of binary only. So how memory devices have been classified? Memory devices have been classified into two things, which is primary memory and secondary memory. Early stages of when these microprocessors have been evolved, there is no such concept of secondary memory. So when I was talking in this video or the further videos of microprocessors, you need to remember one thing. When I was talking about the memory, you need to picture yourself with only primary memory, that is either RAM or ROM. Okay, the primary memory. The concept of memory in 8085 or 8086 microprocessor is completely based on RAM and ROM. RAM and ROM, where RAM is random access memory, and ROM is read-only memory. So why two types of memories are there? Because one is used to store the data and another is used to store the program. Madam, you have already told that memory is used to store the data. Yes, program is one of the data, right? The instructions what we are written is also a data. I already told you that data is in many formats. So RAM and ROM use it to hold one is used to hold data and another is used to hold program. Here ROM is used to store program, where RAM is used to store data. So what is the difference between the data and program? So if you know about the data and program, you need to know about this minimum things. What is that? If we are using any applications, like we are using WhatsApp, right? We are using WhatsApp. So while we are using WhatsApp, the WhatsApp itself is an application, right? So if it is an application, there must be a program to execute that. So this will be stored in the ROM, read-only memory. That program will be stored in permanent memory, that you can access the program but you can't change the program, right? If we are using WhatsApp in our mobiles, are we able to change the program of WhatsApp? No, but we are able to change the data which we are sharing. So the images or pictures or data, text, what you are sending in the WhatsApp is completely the data. So the application itself is a program. The data which you are sharing is the data. Okay. So another example of application is camera. So how we are using cameras? To take the pictures or to take the videos, right? So cameras itself is an application which is nothing but the program, and the videos or images you have taken is the data. So basically the memory which we have been using in this microprocessor in 8085 or 8086 is always the primary memory. In that primary memory, RAM is used and ROM is used. Again, RAM has been classified into two types. First one is SRAM and second one is DRAM. So here SRAM is a static RAM. What is SRAM? SRAM is static RAM. What is DRAM? DRAM is dynamic RAM. Static RAM have been constructed using the flip-flops. Flip-flops are the devices which is used to store one bit of data, right? So, and DRAM is using capacitors. So, we can say that SRAM is quite fast when compared to the DRAM. Why we are not, why we are saying like that? Because SRAM uses flip-flops, whereas DRAM, dynamic RAM, uses capacitors. So, while we are using dynamic RAM, we have been using capacitors. Capacitors, when it is charged, it will be represented as 1, and when it discharges, it will represent as zeros. So, we are not using single capacitor, right? If you want to have more data, we need to have more capacitors. So, if we are using more capacitors, then to charge the capacitors, the power is more taken. So, it will take some time. So, that's why we are saying SRAM is fast when compared to the DRAM. Okay. Here, whenever I was talking the memory, you need to picturize yourself with only RAM and ROM. Okay. Random access memory and read-only memory. So, we have been, this is the memory. How we will store the data in memory? Memory will always store the data in the format of binary. Previously, I have already told that how microprocessors will work. Microprocessor is an integrated chip which takes the input from the input devices and process the data which we have already given as the instruction format or programs, and it will send the output to the output devices. Very good. Fine. Then how instructions in the microprocessor work? So first the microprocessor fetch the data, right? Microprocessor fetch the data. Already the data have been all saved in this memory. So microprocessor fetch the data. Very good. Second, it will decode. So what is decoding? So if you ask, most of the student will tell decoding is nothing but to convert the high level language or any data into the binary bits. It's completely wrong, because while we are storing the data in the memory itself, it will convert it into the binary. So how you are decoding binary to binary? No, it is not possible, right? It is not necessary, because memory itself stores the data in the binary format. So how data will be stored in memory using binary format? So for that question, I would explain this one. Okay, here we are using A equals to B plus C. While you are seeing this instruction, you can able to understand that we are performing addition operation, which is nothing but arithmetic operation, right? Addition operation. Here we are using addition operation between two things. If you are writing the instruction like this, it will consider as an high level language, like using your C programming. We can use this high level language. So here second one is add B comma C. Add is nothing but arithmetic addition operation. We are performing addition operation between two registers. Registers is the another concept. I would like to explain that in the architecture of 8086. Okay. For now, register is used to store the data, temporary data. Okay. Here we are adding two instructions. Add B comma. Here we are adding two data which is present in the registers. So add B comma C. This instruction will comes under the assembly language programming, which we have been using in 8086. Okay, na? Assembly language programming. So this assembly language, these instructions will convert these instructions to binary. It should be converted into binary. Who will convert these instructions into binary? Because machine can't understand this instruction itself like this. It need to be in the binary format. So this is the instruction which is in the low level language format, machine language, binary language of object language. Okay. So these high level language instructions have been converted into the binary instructions using compilers. Again, if you are question for the students what is a compiler, they'll say compiler is the thing which shows the errors if there is any program. No, compilers doesn't show. It will show the errors because it is converting your high level language program into the binary thing. If they are converting to the binary thing, then it will, if any errors is there, they will show. But the process of compilers is to convert the high level language to the machine level language. Here, how assembly language program have been converted into the binary thing. So there should be the assemblers. These assemblers convert the instructions what we are writing in the normal language to the binary thing. Okay, assemblers converts the instructions into the binary thing, and that in data will be stored in the memory. Now, what is decoding? So, understanding the low machine level language is nothing but the decoding. Here you are using one opcode, binary level thing. So, how machine will understand this is the primary thing for decoding. Okay. Now, after decoding, it will execute the instruction. It will perform the operations which we have been written in the instructions. Okay. What is opcode? So, let us consider one example. Okay. With one example, I will tell. If we designed one microprocessor that only performs basic microprocessor that only performs only 4 binary operations, that is addition operation, and for that we are coding it as 0 0, and for subtraction operation we are coding it for 0 1, and for division operation which we are giving 1 0, and for multiplication operation so 1 1. So when we are writing like add a comma b, so what assembler do? Assembler will convert this to the particular opcodes. If it is converting to the opcode 0 0, right? Now assembler will go to this particular table and it will check 0 0. What it should do? Addition operation. So understanding this concept is nothing but the decoding. Understanding the opcode is nothing but the decoding. Like this, microprocessor will fetch the information from the input and it will process the data which we have given as in the instructions or program, and it will send the output to the output devices. Okay, this is the basic things. Now we'll go to binary representation. Okay, I already told that while machine can't understand binary digital data or decimal data, so it will only understand binary data. That's why our assemblers are doing that thing. So while we are using 8086, we always deals with the hexadecimal numbers. So if we already know that the normal number system, decimal number system, and machine level language, which is nothing but binary. So why this hexadecimal number existed? Why we are using hexadecimal number in 8086 processors? Because one thing, so to represent every digit of decimal number system, we have been using binary number system, right? So we need to, if we are giving data, like I would like to give data of add AX comma BX. The data which is present in AX is 91, BX is 21. Can we perform this operation? Yes, absolutely. That's what the microprocessors do, initial microprocessors. Okay, so here we need to perform 91. Here 9 is a decimal number system format, right? How it will perform addition between decimal numbers? So as you all know that it will be converted into the binary operations. Now, how these decimal number systems will be represented in the format of binary number systems? Okay. Here we are having, as I already told, binary number system is having only 2 digits, either 0 or 1, which will be represented as bit. Okay, bit. So these bits, using 2 bits, how many possible combinations of numbers can we use? So using 2 bits, there will be 4 combinations: 0 0, 0 1, 1 0, 1 1. Right? So we can represent 0 to 3. So how I wrote this one? So there is a basic number format of binary number system 8421. You can use 8421 to write the decimal number format in binary. So here, by using 2 binary number systems, we can perform only 4-bit representation like 0 to 3. But here we are having 9. So we will increase another thing. Okay. We will increase. So I will take 3 digit. So by using 3 digit also 001, 001, 010. So until the basic number would be 3 zeros and the highest number would be 3 ones. So by using 3 ones, 421, which is nothing but 7. So by using 3 binary numbers, you can represent only 0 to 7 decimal numbers. But here we are having 9. So it is obvious that we need to increase another combination also. So we are taking 4-bit binary data. Okay, I will take 4-bit binary data. The starting of the number system would be 4 zeros and 0001. So on it will be 4 ones. If we consider 4 ones, that would be equals to 15 because 8421 code. So this is 8 plus 4 12 plus 2 14 plus 1 15. So you can represent 15. But is there 15 in the decimal number system? Binary basic number system? No. The digits which will represent the binary is basic of decimal number system is 0 to 9. So 9. How we will represent 9 in the binary number format? Okay, by using 4 digits we can use 4 zeros for 0 representation, 001 for 1, 2, 3, 4, 5, 6, 7, 8, 9. Until this combination it is necessary. It is required, right? Until this. But the remaining combinations will be left unutilized, right? So 1, 0, 1, 0, this would be 10 if we return in the combination of decimal. Okay. 1, 0, 1, 1, this would be 11. 1, 0, 1, 1, 0, 0, this would be 12. 1, 1, 0, 1, this would be 13. 1, 1, 1, 0, this would be 14. And all 4 ones would be 15. How we are going to represent this 10 to 15? We are initially utilizing only 9, no? So how we are? So that's why this hexadecimal number system came into the picture. Until 9, the regular combinations will work. The leftover combinations will be represented with 1010 will be represented with A, 1011 will be represented with B, 1100 will be C, 1101 D, 1110 E, and the final one 1111, all ones will be F. Okay, that's why hexadecimal number system came into the picture. Okay, if we are already having decimal number system, why we are using hexadecimal number system? Because there is a huge advantage while using hexadecimal number system. What is that huge advantage? Okay, I'll explain it with one example. Let us consider 4-digit decimal number system. What will be the smallest 4-digit decimal number system? It would be always 4 zeros, right? Fine. So what would be the highest number, highest 4-digit decimal numbers? That would be 4 nines. Okay, fine. So let's coming to the hexadecimal number format. Hexadecimal. So what would be the 4-digit smallest number system? In the hexadecimal, 4 zeros and highest 4 Fs. Now tell me, 1 F is equals to 15. So how many possible number system? While using decimal number system, we are having approximately 10,000 locations. If we consider the locations of memory, then here we are using 10,000. While coming to the 4 Fs, how many locations will be there? Calculate. While using 4 Fs, we will be having 64,000 of possible locations. Now tell me, if you are offered any salary using decimal number system or hexa number system, what will you choose? Absolutely, we will choose hexa number system because it is having more possibilities, more number of possibilities. That's why in microprocessor we have been using hexadecimal number system. Okay. So when I was previously I have already wrote one example, add ax comma bx. While doing that additions also, it will be considered in total hexadecimal number system. Addition will be conducted in the microprocessor using binary, but the output will always be the hexadecimal number system. Okay. So coming to the terms used. These are the terms we have been using in the microprocessor. Without knowing this, you are unable to understand the microprocessor topics. Okay. So what is a bit? As I already told you, bit is a least representation of a binary number system. It can be 0 or 1. So what is nibble? Nibble is the combination of 4 binary digits. Nibble is the combination of 4 binary digits. What is a byte? So byte is a combination of 8 bits. Byte is a combination of 8 bits. What is a word? Word is a combination of 16 bits. Or either you can tell word is a combination of 2 bytes or byte is a combination of 2 nibbles. Okay. So what is double word? Double word is 13 bit. Multiple words like 64, 128, so on. Okay. Now coming to the main topic, bus. What is a bus? You can tell that bus is a combination of lines which can transfer the data between the blocks of microprocessors. In the previous slide, I have already told you these are the buses, multiple buses, right? These are the buses which will transfer the data through and through from one block to the other block. So here, bus is used to transfer the data from one place to another place. What is data bus? The bus which holds data bus. Bus which holds data or which transfers data. Which transfers data is nothing but data bus. Okay. Next one, address bus. What is address bus? What is the necessity of having address bus? Okay. When I was telling I need to, here I already told that microprocessor will fetch the instruction which is already present in the memory, right? The data in memory will be stored in somewhere. Like I was here 35. I need to fetch the data 35. So microprocessor need to fetch the data 35 from the memory. Okay. How it will fetch? So it need to have one unique address to find out the data in the memory, because memory is having many memory locations. So to identify each location, memory should always carry an unique address for each location. So suppose let us consider this location is having the address of 1200. So this is the address of a particular memory. To fetch the data from one particular memory location, the microprocessors need to have this particular address. So how this address will be carried to the microprocessor? Yes, this address will be carried to the microprocessor using address bus. That is the necessity of address bus. Okay, fine. Next topic is control bus. So why we are having control bus? So control bus is used to send the signals, control signals. Now, what are control signals? So basic control signals I'll explain here. Okay. So in one instruction, I want to replace the data which is present in 12,000 memory location. Actually, the data which is present in 12,000 memory location is 35. I need to replace this 35 with any other random number like 65. I need to replace that number with 65. You may question that you have already told that the data present in that particular memory location will be stored in binary, but now you are taking it as in the decimal number format. No, that is not decimal number format, that is hexadecimal number format. Fine. But for example, I was considering, okay, we will write the code as 35 only. It will convert, assembler will convert it later. So for to explaining concept, I was writing 35 and 65. But the data will always be stored as the binary. So here I want to replace the data which is present in 12,000 location with 65. So what microprocessor will do? The microprocessor will first fetch the address and it will go to that particular address location. The data in that particular address location is 35. So what is the operation we gave? You need to exchange. You need to dump your 65 data to that particular memory location. So sending information into the memory. So microprocessor is writing information to the memory. So that is one control signal to write operation. So sending some information into the memory, which is nothing but write operation. If microprocessor want to know what is the data present in that particular 1200 location. So to fetch that data in that particular memory location, microprocessor will fetch that data. So what it will doing? Microprocessor is reading the data which is present in that particular memory location. So getting the data from the memory is represented as read operation. These two are the basic control operations microprocessor will perform humongous control signals, humongous control operations, but out of that these two are basic operations. So these control signals will transfer, this control bus will transfer these control signals either to write into the memory or to fetch the data, and read from the memory. This is the importance of control bus. So coming back to what is system bus? The combination of data bus, address bus and control bus. The combination of these three buses is nothing but the system bus. The system bus will transfer the data, address or control signals throughout the system. So now coming back to what is a clock? A signal used to synchronize the operations of an electronic system. A signal which is used to synchronize the blocks present in the system. Okay, clock pulses are continuous. You can say this is one clock period. So you can say that if a clock is a heart in a human system, then the heartbeats which heart generates would be the clock pulses which synchronize total parts of the body, right? Like that, if clock is a signal that synchronizes the system, synchronizes the total blocks present in that particular system. Now, so as I already explained, what is a microprocessor? A microprocessor is a semiconductor programmable logic device that reads the binary instruction stored in the memory and process the data according to the instructions or program we have already stored in that memory and provides the result through the output devices. Until now, we have discussed the basics of microprocessors. So I have been using MUP instead of microprocessor. Okay. Basics of microprocessors. Why we are using microprocessors? Where we are using microprocessors? What is the importance of using microprocessor? And what are the basic terminology used in microprocessors? In further videos, I would explain how microprocessors have been evolved, what are the features and how microprocessors work. Okay, thank you.